might initially think of. Looking glass is a very, very specific English language jargon, which contains a little bit of meaning beyond what most people can immediately see in there. Looking glass is, a rough translation is a mirror, but it's a poetic kind of literature way to refer to a mirror. And most Brazilians wouldn't know exactly what a looking glass is. It's a very rich in American and British literature. And, so if you could explain this a little bit better, I would appreciate it.
His explanation.
Okay, I'll start with the title then. So those of you who are at Darmstadt may remember that one of my talks there was called Joseph's Adventures in Unicode Land. And that was a two-part literature reference. One was to Flatland, which I'm sure many mathematicians are familiar with, but the other was, of course, is to Alice's Adventures in Wonderland. And so I thought I should have a title which kept that. There's also a long-running interest in Alice in Wonderland in the team. Ask Frank about Alice, I think. And so I thought I would go with Through the Looking Glass, which is Lewis Carroll's second book about Alice in Wonderland. The other reason I thought I'd have something about something visual is most of what I want to say here is about sort of graphics things I've been doing Expo 3, really. So that was the link. So this is my kind of Expo 3 talk, I guess. So yesterday was tools. This is Expo 3, and then after the coffee break, I'm talking about packages which aren't team related. So there'll be a change of top for the second talk. Okay, so really things here, I want to talk about stuff that relates one way or another to some stuff that Bruno's provided to the team, which is the floating point unit. So this is the documentation for the user interface to the floating point unit, so XFP, but that made a better one-page. This is deliberately cut off. I spent a long time working out where to cut it off so that it would look good on the screen and be centered. So it cuts off just before it tells you what it does. There was a lot of fiddling around with the include graphics line for that one to get it right. So the point there is that Bruno, a few years ago now, wrote this floating point unit, which gives us the ability to do expandable calculations in LaTeX, and that's available to users as XFP, but at the Expo 3 layer, it's the FP module. And building on that, I've been fiddling around with various things which relate to, or building at least partly on that, exploiting the possibilities. I've been fiddling around with things which relate to graphics and color and images and things. So it seemed like a reasonable topic for a talk. I had originally planned to have all of the drawing stuff done by now, but for various reasons which link in some ways to accessibility, and I'll sort of highlight that, I haven't quite got there. But so this is really about this. So what's the LaTeX 2 environment? And I couldn't talk about graphics and LaTeX if I didn't mention picture mode, because David would be very disappointed. How would he draw his brilliant diagrams without picture mode? That's much too complicated. Picture mode is well, being serious, picture mode is useful for placing, if you want, it's useful for placing other things in an arbitrary sense, and it is a way of a low-cost way of placing boxes in an arbitrary position in a space. But if you wouldn't want to use it to draw stuff beyond that, because we all know that it's implemented in some special fonts and it is extremely limited. But continuing with things David's been involved in, I think almost all real LaTeX documents probably load at least one of color or graphics. Certainly every single document I ever write does as my day job, because I need to do pictures, well, what I'd call schemes, and they're all drawn as pictures and imported as PDFs. Obviously, even though this is in black and white, this will be loading color because it's been done in Beamer, so that loads color automatically. So, almost every document you ever make. And the real key point there is that as well as those interfaces, there are a number of what are called driver files. I've picked out PDF Tech because it's probably the .def because it's probably the one most people load most of the time. The sort of one which David wrote, which is everyone else has modelled them on, is the DVIPS one. It's a sort of archetypal driver file, I think, because if you read the comments in sort of the older comments, they tend to say we've taken this from dvips.def and changed it. And so coming into this, so this is where I'm going to link sort of TUI and Expl 3 stuff. Those driver files had sort of, so the team had written some a number of years ago, and then because different engines had been around, different post-processing, things like Y&Y and what have we, having its own specials, they'd kind of taken on a life of their own, and they'd all ended up being distributed and being managed by different people separately. And that meant that the features available in different drivers, the different def files, had sort of deviated. Heiko had taken control of the PDF tech one and added lots of features which then weren't quite the same in the one for ZTech or the one for DVIPS or what have we, even though it could be, but features which could be implemented in the same way weren't implemented in the same way. And I was interested in re-implementing some of that as Expl 3 drivers, so David and I have kind of, I suppose, taken back control of those. The joke will work for anyone who's from the UK, hopefully. It's a big important topic in the UK at the moment. We've sort of pulled those back in, and some parallel work's gone on. So David's the driver expert, and I just sort of follow whatever he's come up with. But I've hacked around with that for Expl 3, and then we've kind of got the two into line in some sense. But that obviously, so that we'll come to what I've been doing in the Expl 3 ones in a second, but that's been driven by having those two in parallel. But if you want to do more color things, you might look in the TUI world, you might look at Xcolor, and I think many people will be familiar with Xcolor's idea of color expressions and the fact it lets you do mixes, so the basic color support, you have to define each color separately, and that's not always what you want to do. You might then want to do more complicated things. So this Xcolor is something written by the PGF people to do a very specific thing to do with when you want to overlay one coloured block on another coloured block and how you want to handle how they mix together. You might want to deal with colour spaces, so that's looking towards sort of a print workflow and worrying about things like spot colours. So they're all kind of separate. And then if you're doing graphics, I think you might be using Asymptote or you might be using PS-Tricks, but I think increasingly most users, I guess, would think of they're going to create graphical objects in LaTeX documents. They'd be using TeX. At a lower level PGF, and I'll come on to the fact that the different layers there and how that kind of ties in many ways with the team's thinking about how you program code and how that kind of makes what I've been trying to do relatively straightforward. So what I've been doing really is thinking what I would like to do is more or less cover most, maybe not the TeX part, but certainly up to PGF, most of that in Expl 3, and over time be able to move that into L3 kernel so that it's all just covered at the programming layer and that people can then use it. If I can convince these guys that it's a good idea. And him. Chris is hiding at the back, so I have to convince him as well. Particularly about colour spaces and spot colours. So I thought I would just sort of really just go through a little bit of what I've been up to there. So yeah, I'll just point to the 2E drivers. So we've ended up, so just to sort of wrap that story up. So there's now this graphics def GitHub repository, which is mainly David and me, where we've kind of tidied up those drivers at 2E level, and many of the features which had got added to the individual drivers have been moved back into the graphics core, so that it's sort of self-consistent between if you use ZTech or if you use PDF Tech in PDF mode, or if you use PLaTeX, I guess. They presumably load the same things. Yes, I just thought I'd sort of mention that because it kind of links in. So the LaTeX 3 one, so we've got a very long, so these are back in, so those LaTeX 2E drivers have ended up, they're no longer doc stripped out of things, they're all just completely independent of each other. But rewriting from scratch, I've gone back and tried to pull back together the things which can be done in docstrip back into a single source file at the moment, which is just called L3 drivers, and at the top of that you find loads of lines for for that. And what that file is trying to provide is the lowest level of abstraction of what you need to know. So for stuff working with drivers, you do need to know the kind of form of the arguments things want quite often, because you can't, if you're creating specials, you have to know what the specials are that that particular engine needs. But there are some levels of abstraction one can make. So for example, if you're rotating a box, you might need a matrix transformation for that. The exact form of the matrix transformation depends on the driver, but the idea you need a matrix transformation I can abstract, so I provide at that level a sort of abstract idea of you need a matrix. Well, actually, I provide the idea if you need a box rotation, because you can abstract it one level further, because DVIPS does it by just having an angle. So the idea there is really to provide that lowest level of support, and that's where things link to accessibility, I guess, because that file is being built up as I add higher level functionality. It's clear from the accessibility discussions yesterday that one area to consider is the sort of abstractions that are needed at that level for accessibility. And they link to some things I'm going to say I haven't done for drawing, and that's what's quite interesting, because some of the same ideas come up for certain aspects of making drawings. Yeah, colour. So what have I been doing there? So I think most people will be familiar with Xcolor. So it has this idea of colour expression. Take advantage of the fact we've got a nice board. So it's things like this idea of you can take your named colours and you can use an exclamation mark to separate out a sort of an amount, and you can build up the idea of you can mix them together. Xcolor, so I've put up here, this is its standard colour expressions. It also has a much more extended version, which I haven't tried to implement at the moment because I'm not sure if anyone actually uses it. So what I've been trying to do there is come up with a set of Xpl3 interfaces for setting driver level colours using this idea of Xcolor type expressions. But rather than it being an add-on, starting with the idea that that's going to be built in from the start. And where does that link to the FPU? It links to the FPU in that doing those calculations in a class, if you read through the Xcolor code, doing lots of calculations of that form, they're all floating point calculations in the end, and it gets quite painful, particularly because you have different color models. So red, green, blue, cyan, magenta, yellow, key. That's on my next slide. It occurs to me, yes. There's different models. And you need, if you're going to have expressions, so say I took an expression where I put, rather than blue, I made that cyan, then I need to make a decision about converting between one model and another so I can actually carry out that mixing. Color model conversion is extremely complicated because there's all sorts of things about the way light behaves, but I've gone there with exactly the same implementation as the Xcolor package does, except because we have a floating point system, rather than have to have lots and lots of lines of manipulations of different dimensions to move the values around and to shuffle them into different places, I can just write the expression out in the code. And so it comes out a lot cleaner, and you also we don't get into some of the rounding issues that you get where if you're using as most people do, if you're using dimensions to do your floating point calculations, you always end up worrying about rounding errors. Spot colours are a bit interesting because we're still not agreed on the team what a spot colour is. Or not all of us are agreed exactly what a spot colour is. What? I know what it is. Well, you know what you think it is.
So would you agree with your printer?
Yeah. Well, the question there is, what does a spot colour mean if you're not talking about something that's printed, really? If you're talking about what's the meaning of a spot colour in a PDF that's only going to be projected on the screen? Yeah, but it's not printed. So should you call it a spot colour or should you call it something else? Yeah, exactly. Anyway, that's a detail that we can talk about at coffee time. So really, the idea there is to try and provide some simple interfaces for colour. As I say, at present, I'd be intrigued to hear if people do use Xcolor's more extended syntax beyond just the simple mixing, because I've tried to understand what they're for, and I can see it sort of intellectual sense, but I can't see anyone ever wanting to put them into a document. They seem completely over the top for what a user would want to do. I'm going to point out that these expressions don't look like any other kind of mathematical expression, and I did wonder whether they should look like normal integer expressions, and I decided because they're rather restricted, the X-color syntax is probably right, because you don't want to have because you need keywords for the colors you have, and you need some simple way of not having the syntax bite you on the bottom, really. So I felt that X-color, again, I'd be willing to listen to alternative views, but I personally think the X-color syntax works quite well. So there's that, and then built into that is the idea that you can force a particular color model. So obviously, particularly people might want to force grayscale coloring, but because we have the FPU to do those calculations, that's all trivially easy. Oh, another question during the talk.
Yeah, well, the PDF has, a strange concept of color model.
Yeah.
A page in PDF can have anywhere between, 1 and 6 or 7 different color models
Yep.
on the same page.
Yep.
And is this going to allow you to do an automatic conversion of the color model? Or
I've got some of that is done. There are some bits. So if you look at the color space package from Xavier, it covers some of this, but his model is fixed in the maximum number of different colors you can use. So partway through, I haven't finished it yet. I can see that you don't have to do that. You can make it flexible and have it open-ended. You just have to track more data structures you're going to write to the PDF, and that then links back to the idea of needing to do driver work to put stuff into the PDF. Well, maybe at the end, because I'm mindful that the live stream won't be able to hear the questions, or might not. Unless is it directly going to?
Okay, well, it was just a sort of generalisation of what the previous question.
Yeah. Okay.
Sorry for the interruption.
It's all right. It's okay. Former boss of mine really liked it when talks had questions during the. It means that people are enjoying it, and it means you don't forget the questions as well, because if you wait till the end, you forget them. Okay. Yes. Interconversion is non-trivial. So yeah. If you read the X-color documentation, which is excellent on this, it points out that it is extremely complicated because of the physics of different color models, the interconversion. As I say, I've just gone with the same approach it uses on the grounds that's what people are used to. Whether it's right or not is not something I necessarily want to get into. So that's yeah. All right, yes. What's motivating me to do this? Particularly, what would motivate me to look at drawing graphics? There's a sort of desire to have this feature complete idea for Export 3 that it should, in the end, be able to cover all reasonable things. So we want to have this idea that we want to provide documented interfaces at a code level for all programmatic features. And drawing is one that people do a lot of, and so it's perfectly reasonable to want to cover that. You get API consistency that way, so hopefully I stick to the same rules as we use other things, and so we should be predictable within that sort of framework. Because particularly if you look at TeX, one of the problems you run into there is if you try to put bits of TeX code into a Export 3 code, you run into problems because of the cat code of spaces and the fact that we use colons to be letters, and then that messes up the whole PGF parsing because it uses colons for something different, and things go badly wrong. So that's not great. And particularly in the context of this talk, the real thing is I'd like to be able to exploit the FPU. So as a PGF, particularly PGF plots user, one of my things I run into occasionally is you get dimen too large errors, which tend to come when you use very small values in PGF plots. And that's because PGF TeX uses dimens to do its floating point work, and it has to do some scaling to make that workable, and sometimes the scaling code runs into problems, and then you have to work out how to fix it some other way in your document if you're doing. I do quite a lot of scientific plots, and occasionally I have to hack around how they're going to work. So the reason there is that the LaTeX 3 FPU is expandable, so you can just stick it directly into places that you can't with the PGF one is done by assignment, so it can't be done that way. And so really that's my other motivation. And the other reason, I guess, is because in a way, what Tiltanto has done in PGF and TeX really aligns with many of the thoughts the team have had. So you have this idea, so TIL has this idea of 3 layers, and they sort of match up. So you've got a system layer, a base layer, and interface layer is how TIL describes it. So in TeX, you'd have the system layer would be a macro like PGF sys move to, which is the most basic abstraction you can have for moving your graphical state from one place to another. Then you've got the base layer, which is PGF path move to, which is the interfaces that things are meant to be coded in, although TIL doesn't always stick to its own rules. And then you have something at the user interface, and I think the nearest I could come up with is the TeX draw command. It's a bit complicated because this covers, the draw command covers a multitude of base layer things. And in many ways, that maps quite nicely to what I've been trying to do in what I've called L3 draw. So we have, or Expl3. So at the system layer, it's what I'd call the driver command, the minimum abstraction, again, we can do. So that's driver draw move to, in our case, which takes, as you'll see, 2 arguments. So that's an X and a Y. Then I've got a base layer, which is the L3 draw, so draw path move to. And that only takes 1 argument because it takes a coordinate pair. So Bruno added that support to the FPU, so we can directly take coordinate pairs. There's a reason I've gone for that rather than having an NN at that level. We'll come to that in a second. And then interface, well, currently that would be out of scope for L3 draw, which is a code level. But one could imagine making an Expl3 based implementation. Oh, yes. OK, so I've got some demos. The reason that this has got 1 argument and it takes a common separated pair is what I have been aiming for is, given the fact that TeX is built on PGF, and that's built in like 3 layers which are somewhat separated, one might hope that you could, if we have API compatibility at the base layer, one could build some glue and run TeX on top of Expl3 based drawing commands. Now there are some issues there because TIL describes these 3 nice separate layers, and then you read the TeX code and you realize that a lot of it's actually not done that way. So there might be some problems there. Also, because of the fact they use a non-expandable floating point approach and their return system is different, there are some issues. But I think at least you could hopefully be able to use the TeX code as a model. So I just thought I'd finish off by showing hopefully a few examples of the code at work. So these are all essentially, I looked through the TeX manual, I took some of their examples and I recoded them to make sure they would work. And they do. So this is, well, I used those to make sure I hadn't messed things up. So this is just showing off a bit of simple drawing. So typical Expl3 SAR, so we have a begin and an end, draw begin, draw end, and then you'll see I've set the corner arcing here, which is where we get the nice curves. So that's a PDF feature ultimately, arcing corners, but you set various PDF specials or DVIPS instructions for PS to PDF or whatever to PS. And then we have a series of things we move to, put a point, so this is a polar thing. And we get to, the other thing we get here is this is what I mean about API consistency. Because this is all in Expl3, we can then use the Expl3 way of stepping round a range. So stepping round to do these different points, doing a polar positioning. So I've got int step inline, which is a standard Expl3 command. And you can then draw your lines, and you can draw your points. And then you close your path, and then you use it. And so some of this is still a bit experimental, but I've stuck with the way that things are done in PGF broadly. So they use the idea that you have different ways of using a path. So you can fill it, you can stroke it, which means you draw around the outside. You can fill it and stroke it. You can use it as a clipping path, or you can just chuck it away, which may be useful in some circumstances. So I've gone with the same interface there. So again, because I've written this linking to Expl3, so we have this idea of coffins, which are, for those of you who aren't familiar, they're boxes with handles. And the idea of coffins is that you can place them and you can control where you're placing them because they have these different handles that describe, well, the default handles are the baseline, the top, the bottom, the centers, vertically and horizontally, and the left and right edges. But one can add more, and you can do things with coffins. And so here, because this code is aware of coffins, so this is something you wouldn't find in PGF because it doesn't know about coffins, but my code does. So you can put a coffin, which is the text, into a drawing, which is the line here. It's a very simple demo, but the idea is that we can use the coffin. So these are the coffin handles, horizontal center, vertical center, which is why this line probably isn't, I probably should have made it colored. It starts in the middle of that S. And then, yeah, just to show really that things are expandable, which is the difference we get. So if you want to find the intersection of two circles, that's quite fun. It's quite fun if you write it expandably, but it works. So you can take these. So you need to be able to find intersections to be able to do the kind of things that TeX does, where you can do all this clever relative positioning and knowing if lines overlap and everything. I haven't done all the relative positioning yet. That's still to do. But you'll see here we have an expression which finds that this is two circles, and this finds the first root intersection between the circles, center 0, 0, radius 1 centimeter, and I just made a deliberately complicated expression. So the one with a center at root 2, root 3, again of radius 1 centimeter, and then it tells us what it came out with, which is there apparently. Well, you wouldn't normally want to look at the values, but the point I was just trying to make the point that it is done by expansion, so you could.
Interesting line splitting.
What?
Interesting line splitting.
Yeah, that's because my little demo environment just tries to put them on the same line, and that was where the break came. There's no spaces in it because so it's not easy to break. So yeah, right arm over 3 to come, I think. Cricket. Right up halfway through and over. Right arm over. I'm right-handed. 3 to come. Three balls of the 6 to come. You should know about this, Will. You're from Australia.
I know. You've lost 95% of the audience already. Don't dig any deeper.
Anyway, my point is, I think some work done, some still to do. So much of the PGF core is working. The basic drawing stuff all works, but I still need to do driver work because what I haven't covered, and I say what in many ways links to accessibility, is things like transparency, reusable objects, and a lot of these things need sort of rather complicated PDF features to do with objects. And so they link through nicely to accessibility because they need the same low-level driver support for that kind of concept. So I need to do that for drawing. I need to do it for accessibility. So that's probably going to be next thing on my list, sort out the driver level for that. Yeah, perhaps interface to TeX. I'm not sure that's workable because it sounds like a great plan until you start reading the TeX code and you realize that it doesn't just use those nicely defined interfaces. It quite often goes round into the internals of how the things are implemented. And yeah, that's what I wanted to say, really. So thank you very much for your time.
Questions?
Okay, putting on a bit of leg spin here. I'm deliberately sort of pinning you down in public here, which I apologise.
It's all right.
When you're working on this sort of stuff, do you have what I would call a latex graphics model in mind at all?
What do you mean by a latex graphics model?
Well, no, I'm asking you if you even have the concept. Is actually. I mean, a lot of the words you've been saying relate to well-known graphics models, like the very complex stuff. Well, I'm talking about graphics and colour. Very complicated things in PDF or the rather simpler ones.
Okay, I see what you mean. What my feeling is, they're well-known, but they're basically at the user interface position. Most of that stuff is basically right. I think
I'm not saying what that model is. I'm just saying, do you have in your own mind an idea that there is a latex graphics model?
Yes, I suppose so.
Well, all I'm suggesting is it might be a good idea to document that, either by saying we're using the same model as PostScript or PDF or...
Okay, I see what you're getting at.
What I mean?
Yeah, okay.
Then it would be easier to talk about the user level.
Right. It's pretty close to the PDF model, I think it's fair to say.
I suspect it is. I'm just thinking it might be a good idea in documenting this.
Fair enough. I think somewhere in some of the L3 draw code I have more or less said that.
A lot of people won't need to know about the other two levels and so on.
Yeah,
the user level commands will make sense to anybody who had thinking in the right way.
Broadly, I would say it's basically the PDF model.
And for our own purposes, I think it's useful if we do have.
Yeah, fair enough. Yeah, fair enough.
Idea of a model.
Yeah,
I mean, not as a fixed thing.
No. It's the thing. There are some places that you want to do things slightly differently because they fit better with a text.
I'm not really talking about the implementation. I'm talking about the way you describe it and the.
Yeah, fair enough. Yeah, similar to. Can I go very similar to PDF?
Yeah, sure.
As an answer to that, then.
You.
Thank you.
Okay.